Hello, Assalamu alaikum. Can you hear me? Alhamdulillah. Okay, let's start now. And remember last time we did LU decomposition, and I told you the LU decomposition is possible by two different variations. LU decomposition by Dolittle way and LU decomposition by Crotts way. Last time we finished the LU decomposition by Crotts Dolittle way. Today we will do inshallah Crotts. I just give you the quick review. For LU decomposition, we have to do 3 steps. The first step, what we have to do, we have to convert A into ln U. L is a lower triangle matrix and U is upper triangle matrix. And then your system become AX equal to LUX equal to B, right? Because you decompose A into the form of L and U. And then you do the second step. And the second step, you do what? You use L from step number 1. Y find out equal to B given by the teacher. Sorry. So we have solved this forward substitution we use, and we will get inshallah Y. And the third and the final step, it is UX equal to Y. U we get from the first part, Y we get from the second part, and inshallah, this will give you our solution of the system, which we call is X, by using backward substitution. Now here, we have a 2 case of using this 3 step. The first one we already finished, which we call is a Dolittle method. And the Dolittle method is what? Your L should be unit lower. Unit lower mean the diagonal element of L must be equal to the 1. And then we have to find rest of the element of L and U, and then we can find the solution here. And remember that one in the case of the Dolittle method, I give you the formula to find determinant of A always equal to determinant of U. And also, if you remember last time I mentioned you how to find element of L and U. We have a 2-way to find the element of L and U. One is a by direct multiplication. That means you just multiply L and U and then equate with the given A. Then you have to solve the 9 equation and you find the 9 unknown elements, 3 for L and 6 for U. And this is slightly lengthy process. And I told you that always use simple gas elimination to find the element of L and U in the case of Dolittle method. And simple gas elimination, you remember, is what? We use A to convert into U. That U and this U exactly the same. To convert A into U, we use 3 multiple, and that 3 multiple are the element of L. That's we finished last time, please. We did, I think, 4 examples last time here. Now we talk about today the second variation of LU decomposition, which we call it the Crotts method. And what is the Crotts method? It is opposite like Dolittle. In the Dolittle, your L was a unit lower, but here your matrix U was the unity on the main. That means your U should be unit upper. U should be unit upper things here. So for example, and here, please remember one point here. You cannot use simple gas elimination to find out the element of L and U. You have only one choice to use direct multiplication. For example, I give this example and I say find LU decomposition of A only, no solution. So what you have to do, You know what is L? In this case, in the Cross method, the shape of L is this one. 6 unknown element we have to find out. And in the case of upper, your upper should be unit upper. Unit upper mean all the diagonal element in the upper should be 1 from the start. It's mean 3 element we have to find out, U12, U13, and U23, and 6 element for L we have to find out here. So how can you do here? By direct multiplication, as I told you. You cannot use simple gas elimination in the Cross case. So you direct multiply, you multiply this matrix with this one, and inshallah you will get this process, this element of the new matrix we have here now. And then we say they are equal. So you can say this one, that the first column of A is equal to the first column of this multiplication, which I did like this one here. So sorry, here I give this one here. And then you can find out what is L11 is a 1. What is L21 is a 6. What is L31 is a 2. Where directly you have the value of first 3 element, which I give here now. Then you use the same way. The second column of this unknown matrix is equal to the second column of given A matrix, which is I give here now. And then you can find out the other 3 possible unknown element. And then you do the last step. The third unknown elements equal to the given A third column, which is 3, 4, 6 is equal to this one. And inshallah, you will get the rest of 3 elements. So all together becomes 6 and 9, sorry. And then we have a 9 unknown, 3 for the L, and 6 for the L, and 3 for the U. And that is the LU decomposition we have here now, please. So here, please, you have the choice to use the direct multiplication. You cannot use a simple gas elimination in the case of the Cross methods. I give you the complete example. He says solve the following linear system by LU decomposition using Cross method. Now we have to complete the problem, and LU decomposition has a 3-part. A equal to LU, Ly equal to B, and Ux is equal to Y to find the solution here. So he says solve the following linear system. So first step you have to do what? You have to find the LU decomposition of A of previous example exactly the same. So we already have the element of L and U. We already calculated from this one that I mentioned that we calculate the element of in the previous example, example number 3.29. So this is the things we have. Now we find the solution. So we have to do the second step. And the second step is what? Ly equal to the B. L is given this one. B given by the teacher. And you have to use this formula, and then you have this one. Then you use the forward substitution. And in the forward substitution is what? You know Y1 is equal to 1. And you go down now. Put Y1 here, and you can easily have the value of Y2. And inshallah, you will get 1. And go down again. You know the Y1 is 1, Y2 is 1. You can easily find out the Y3, which is equal to 1. So that means the second step, you have to use the forward substitution. Forward substitution means from top to the bottom we have here. And then we do the last step to find approach to the solution of the linear system. And that step is Ux is equal to Y. We already know U is this one. And X, Y, we just find out 1, 1 minus 1. And that's to give you here. Now you put in the system form. So we have now When you have the upper one, always use backward substitution. When you have a lower one, always use forward substitution. Now you use backward substitution. You can easily find out x3 is equal to -1. Put x3 -1 here. Simplify, inshallah, you will get x2 is 3. Put x3 is -1 and x2 is a 3 here. And inshallah, when you simplify, you get the x1. And that's a solution of the linear system. So this is called the Crowd's method. And in the Crowd's method, as I told you, like Dolittle method, we cannot use a simple gas elimination method to find the element of L and U. So only one choice left, which is a direct multiplication. Now, I developed myself a shortcut, because direct multiplication, as I told you, the direct multiplication is this one. Direct multiplication is a long process. First, you have to multiply these two matrices, and you must be very good in multiplication. If you make small change, small mistake in the first step, all the things become wrong. Let's say you are very good in the multiplication, and you did the fine, this one, the right multiplication, but still you have to solve the 9 equation to find 9 elements. It's a slightly lengthy process. So therefore, I give the shortcut myself. I develop the formula myself. And that formula I use here in that case, I think. Yes, he says solve the following linear system by using Crowd's methods. Now, what I use here, I use this rule. And this is I developed myself here, please. Is a shortcut, very simple one. And to develop this rule, we have to start with I into A. A is equal to, when I say, please, when I say A equal to unit matrix I and A, and this is true, because I is a unit matrix, and unit matrix multiplied by A, you will get the original matrix here. Now, what is your job now, please? Your job now is to make the A, do the process, all your process on A, all the operation on A, and convert your A into the unit upper. Into the unit upper. So when you convert into the unit upper, any element you change in A, put in the corresponding I position, and that you will get the L and U. Your I will be converted into L and A will convert into unit upper, and that's alhamdulillah the jawab of the problem here. For example, we have this example. First, we have to find what is over A. A is the coefficient of the unknown variable. 1 minus 1, 3, 2, 0, minus 5, 0, minus 2, and 1 is here. And then we have to take this one, IA. This is your I. So what is your job? Your job is work on this one, this matrix here, and you have to convert into the unit upper. What is unit upper? Unit upper mean the diagonal should be 1, 1, and this and this and this element must be equal to the 0. That's the things we have here now. Because if you look for the unit upper, what is the unit upper we have here? Unit upper matrix is look like what? It is 1. And you have some element. You have some element. Then you have 0. You have 1. And you have some element. And the last row you have here is what? 0, 0, and the 1. If you can see, please, here, if you want to convert this into the unit upper, how many elements you have to change, please? Any student? If you want to convert this one into the unit upper, how many elements you have to check? Any student, please?
Three.
We have to check 6 elements. First, what is your first job? The first job you have to check?
The diagonal must be 1, right?
This should be 1.
Yes.
If it is not 1, what we do? We taqseem this row by that number to make it 1. For example, here is 4. How can you make 4 into 1? You taqseem this row by the 4.
By 4, yes.
Right? To convert into 1, sorry. To taqseem by 4, and it will become 1. And then you have to do what? Make this one and this element equal to 0.
0.
So this is 3 element you check. Then you move to the second step. You have to check what is this one here. If it is 1, alhamdulillah. But if it is not 1, we have to make it 1.
We have to make it 1, yes.
And same thing, we taqseem here, only here. And then we make this one equal to 0.
1.
0.
No, this one is 0 and the upper is 1, right?
Yeah, this is, we have to make it 1. So it means we have to play with the 6 element, 1, 2, 3, 4, 5, and 6 to convert your A into this one. If it is here is 1, no need to change, right? But if you change anything here to make it unit upper, you put in the corresponding position. For example, if here is a 4, you have to make it taqseem this row by 4, right? And then you have what? You have 1, 2 by 4, 0 by 4, like this one. And then you had changed your 4 into 1. So you put here is what? Is a 4. Then you make this one and this one equal to 0. So when you make this one and this one equal to 0, just put exactly the same thing here. -1 and -3. Anything you change here, you put in the corresponding position here. Is that agree? Let's I do the example now. We have 1 is already 1, no need to do. So it means our job is to make this one and this one equal to 0. So we have to put -1 and -3 here, and then we do the operation to make it to you, because to convert this one into 0, how can you do? You multiply first row by -1, subtract here. So we have -1 subtract is a 0, -1 subtract is a 2, 0, you have a -2. You multiply first row by -3, subtract here, and this will be changed, and you have this position now. You finish your first step. You change only 2 elements, which is -3 and -1 and -3 to make it 0. So put change element in the corresponding position. What is your next step? Your next step should be what? You have to check this one. This should be equal to what? Is a 1.
1. Yes.
So we taqseem this row by the 2. And what is the shape we have? Is a 1 and -1, right? But
Yes.
we change this position. So that position we have to put in the corresponding position in place of I. And what is next job? To make this one equal to 0, the simple way, like. And so we change this one 0. So we put 1 in the corresponding position. And when you simplify, you have this position now. We finish the second step. And what is the third step? This should be equal to what? 1.
1.
So we taqseem this row by 1. So it is become 1, like this one. So we change this element. So when we change any element in the right hand side, we'd put in the corresponding side, and that we put here. And this is your L, and this is your U matrix we have here now. Any question, please? If you not understand, I will repeat again here. So my advice is not to use the direct multiplication, because direct multiplication will take time, and you have a chance of mistake here. So my advice is to use this my method here. Very simple one. You have to start with IA equal to A, and then you can say convert your A into unit upper, and any element you change into convert into upper, you can put in this position we have. And then when you have L and Y, things become very simple, because you say find the solution. So to find the solution, you know, second step you have to do Ly equal to the B. L you just got now. B is given by the teacher. And then you use forward substitution. Inshallah, you will get the value of Y. Y1 is 3, Y2 is 2, and Y3 is a -4. And then you do the last step to approach to the solution, which is Ux is equal to Y. You just get in this step, which is this one. And Y you just find in the previous step here, which is 3, 2, and 4. And now you use backward substitution, and you will get, inshallah, the unique solution of it. So this is your choice now. Either you use direct multiplication or you use the method I gave you here, this one. This is the example I gave in the last time final exam. Very good example. He say use LU decomposition by the Cross method to find the value of alpha for which this following matrix is a singular. What does that mean? Following matrix is a singular mean the determinant of A is equal to the 0. What is the determinant of A, please? In the case of the Cross method, I told you the determinant of A in the case of Dolittle method is determinant of A always equal to determinant of U. Can you tell me what is the determinant of A in the case of the Cross method? Any student, please? We know what is A. A is LU. What is the determinant of A? Determinant of L into determinant of U. What is the determinant of U in the Cross method, please? What is the determinant of A in the Cross method?
Like the first one, right?
No.
Yes, diagonal with ones and zeros.
This is a Cross method. This is a Cross method, right? That the diagonal element of U should be equal to 1. So what is the determinant of A, please? Can you tell me, any student now? La ilaha illallah Muhammad Rasulullah. Determinant of A equal to determinant of L, determinant of the U, right? Can you give me what is the determinant of U?
1.
1. So it means what is this one equal to?
Determinant of L.
Yeah, this is the things I want here now. In the case of the Dolittle method, determinant of A always equal to determinant of U. But in the case of the Crowd's method, the determinant of A always equal to determinant of L. What is the determinant of L from this formula, please?
L11, L22,
Yes,
L32.
L11, L22, and L. This is the diagonal element multiplication we have here now. Okay, remember that one point, please. Let's go to the example we are dealing with that. He say, use LU decomposition by the Crowd's method to find the value of alpha for which this following matrix is singular. This is the first step. Singular mean you never have a unique solution. Then the second step, he say, compute the unique solution of the system by using the smallest positive value of the alpha, smallest positive value of alpha. So first job you have to do what? You have to convert your A into LU, and I use again the method here, my method, A equal to IA, which is this one. And so no need to make it 1, already is a 1. So you have to make this position and this position equal to what? 0. And then you can have here, you just put here. And after that, you have to put this position is equal to 1 and make this one 0. And when you do the same step, you repeat like me. I did in the first example, exactly the same thing. You will get the value of L, and this is the value of the U here. But as I told you, if you not properly understand here, you read that one again or not, then you use a direct multiplication, exactly the same job you will get here. Now you can see here, he say the first part, find the value of alpha for which it make it singular. And singular mean the determinant of A must be equal to A, must be equal to 0, because singular always mean determinant is 0. And then you can do, what is the determinant of L? 1 multiplied by alpha minus 1 multiplied by 2 minus alpha minus 2. And when you make tahleel of this one, you have this one. And you have alpha minus 1. So these are the value of alpha, which make your matrix A is a singular. Now, what is the second part of the question? He say, the second part of the question, he say, compute the unique solution by using the smallest positive. So which smallest positive integer you will choose? Because this make you problem. So we have to use very next smallest positive integer, which is equal to what? The 2, because the smallest positive integer are 1. Then 2 positive integer are what? 1, 2, 3, 4, 5, 6. Smallest is 1. But 1 give you problem, because 1 make you what? A singular. And yes, singular we cannot use here. So it's mean to find the unique solution, we have to use very next integer, positive integer, and which is what? Alpha equal to the 2. So now this is your L and this is your U. Just put L in L, put alpha equal to 2. Inshallah, you will have this value. And then you solve this system. Forward substitution, you will get the solution for Y. And then you solve the last system, is upper system. And your upper system is what? Is Ux is equal to Y. And then you find here, what is your U? This is your U. Only that in place of alpha, you have to put the 2 because you choose 2. and then you solve the backward substitution for this system, and inshallah you will get the required unique solution of the linear system we have here now. This is we call LU decomposition by the Cross methods here, please. So please remember that one here. We did the Cross method by two way, by Dolittle way. They have the same procedure, only the element of L and U are changed here. In the Dolittle method, you remember what is the determinant of A? Determinant of A always equal to what? Determinant of U. And in the second variation, which we call LU decomposition by Cross method, and in the Cross method, how can you find the determinant of A? We have the formula determinant of A always equal to determinant of L, and determinant of L or determinant of U are what? Only the multiplication of their diagonal element. Any question, please, you have here? Is okay? Say please yes or no.
Yes, it is clear, inshallah.
Inshallah. Then there is a topic called inverse by Cross method. No, this is not with us, okay? So we finish LU decomposition of the methods here now. Now we have finished the both direct method, and we did two direct method. One is called the gas elimination, and gas elimination, you remember we did by two different way, by simple gas elimination and by partial pivoting. And the second direct method we did LU decomposition, and LU decomposition also we did by two way, by the Dolittle method and by the Cross methods here. Now we will do the iterative method for solving the linear system. But before I give you the iterative method, I give you two special matrices here. The first one is called strictly row diagonal dominant matrix, or just ignore because we have strictly row and strictly column. But in 254, we discuss only strictly row. So I will not call row, I will call strictly diagonally dominant. And this is a definition of the strictly diagonally dominant matrix. Definition is this. What does this mean? This means if your matrix is a SDD, SDD means strictly diagonally dominant matrix. It's mean all its diagonal element, each row in the diagonal element must be bigger than some of the other element in that row. For example, what does this mean? It's mean 7 must be bigger than some of the 3 and 1. We don't care about negative because we consider it in the absolute sense. So this is true. 7 is bigger than some of the other element of that row, which is true. 7 is bigger than 4. Then 6, the second row, second diagonal element must be bigger than the rest of the element in that row. And this is also true because 6 should be bigger than this one. And yes, it is true, 6 is bigger than the 4. And what is the last one? 8 should be bigger than some of this element. And this is also true here. 8 is bigger than some of the other element in absolute, which give you what? 8 is bigger than C. So it's mean your matrix is SDD. SDD matrix mean each row diagonal element must be bigger than the sum of the rest of the element at that row. Then we call SDD. This matrix is SDD or not? Any student?
We have to check first.
No, you can see directly. No need to check here.
Yes, no, because the 6 is not bigger than 7.
Yeah, 6 is not bigger than 7. So no need to check the second one and the third one. The second one is okay. 7 is bigger than 6. Third is also okay. 10 is bigger than 9. But the first one is not satisfied because 6 is not bigger than 7. This means this B is not STD here, right? So this is the things, please remember that one. This is very important when we deal the iterative method solving the linear system. We need this definition. That's the things I mentioned here. 6 is not bigger than 7, therefore it is not strictly diagonally dominant here. Now, this is a good point of this one here. Very good theorem here. And this is the things we have here. Now, if your matrix is strictly diagonally dominant, the strictly diagonally dominant matrix always non-singular. And when you use simple Gauss elimination, your diagonal element will be never 0. That means when you use a simple Gauss elimination method, if you remember, in the simple Gauss elimination, what we used to do? We used to do, if the diagonal element becomes 0, we interchange 0. But if your A is STD, we never interchange 0. Why? Because the diagonal element never becomes 0. And also the third condition, the matrix A has a LU factorization, because I told you every matrix has a LU factorization, LU decomposition. No, some special matrix are. And one of the special matrix we discussed now, if A is STD, LU decomposition is always possible. So this is the things here, and this is a column, please. No, this is not with us here now. We will not talk about here. And this is, we talk in the column sense here, but no, we only do the row wise here now. So this is not with us here. Now, second things we need, no, this is not regular or like this one. We need, before we start the idea of the iterative method, we have to use the norm of the vector and the norm of matrices. And the idea of the norms behave like absolute. You remember, you have the idea of, if you are X is a real number, and real number mean maybe negative, maybe positive, maybe 0. Then how can you say absolute of a number? We denote by this one. An absolute of a number is always equal to what? Is positive when your X is positive, and it is equal to negative when this is a negative here, less than 0. But absolute of any number always positive here. Now, when you are dealing with the number, you always use the idea of the absolute. Now, in our case, what we are doing linear system. And in the linear system, what is your A? Is a matrix. What is your X? Is a column matrix. What is your B? Is a column matrix. And for absolute of a matrix, no, this is a wrong word, because we never use absolute for matrix or the vector. We use absolute only for number, not for this one. So therefore we can use the norm of a vector and the matrix. Is the same idea. This is a notation you discussed in 107, I think. This is the norm of a vector is always positive. And norm of a vector only equal to, like we say, absolute always positive. The norm is only 0 if all the element of a vector is 0. And if you multiply a vector by any real number, and of course, for real number, we never use norm. For real number, we use what? Absolute. So when we have this multiplication, then we can convert into the absolute of alpha, because alpha is a real number we have here now, and x is a vector we have here now. So this is the thing, the difference we have. And sum of the two vector norm is less than or equal to this. And norm, in 107, you discuss norm in L2 norm. But in 254, we use only one norm idea definition, which is L infinity norm of a vector. And what is the definition of the L infinity norm of a vector? L infinity norm of the vector is the maximum element in absolute sense. The element of a vector is a number. So what is the L infinity norm of a vector? L infinity norm of a vector is the maximum element of a vector in the absolute sense. For example, this is your vector, please. It has 3 elements. What is the L infinity norm of this vector, please? Any student?
5.
Is a 5 the maximum element in absolute sense? And the maximum element in the absolute sense, which I calculated here now, you have to find maximum in absolute -5, 3, and -2 absolute. And of course, which give you the maximum value is a 5, is the L infinity norm of, I define here in the book L1 and L2 norm, but this is not with us in the 254. We only have to discuss L infinity norm of a vector here. Then the same way we can discuss the matrix norm, because your vector is also matrix, is a column matrix or row matrix. So same condition you can have here now. The norm of a matrix, any matrix, always positive. Norm of a matrix is 0 only. If your A is a 0, 0 mean your A is a null matrix. Null matrix mean all the element of A are 0, 0. And you can see the unit matrix norm always equal to the 1. And if we have, you multiply matrix by a real number, then you can make separate by absolute sense for the real number, where A is a matrix we can have here. And sum of the 2 matrix norm is less than this one. Multiplication of 2 norm also less than or equal to this one here. And this is a condition generally we will not use. We use this one, the 6th condition in the coming topic here. And also the same thing, we can define L2 norm, L1 norm, and L infinity norm of a matrix here now. But we discuss only L infinity norm, as I told you, for L infinity norm for the vector and L infinity norm for the matrix case we have here now. What is L infinity norm of the matrix here? Very simple one. Sum of the element of each row in the absolute sense, and then the maximum row. I repeat again, you have the, for example, 3 by 3 matrix. So you have a 3 row. You just make sum of the element of first row in absolute sense, then the sum of the element in absolute sum second row and the third, and which row is bigger? That is called the L infinity norm of the matrix here. For example, I give this definition. What is the L infinity norm? What is the first row give you in the absolute sense? Sum of that one. What is this one? 7. I'm right? 4 plus 2 plus 1, because we are talking in the absolute sense. So first row is a 7.
Yes.
Second row is
10.
10. And the third row is also
10 also.
10. So what is the L infinity norm of a matrix? L infinity norm of the matrix is the maximum row. And the row you have the 2 the same, so no problem. So this is called the L infinity norm of a matrix that we need here now. This is small 2 topic we need for the case of the iterative method. That's what we have to discuss now. Very simple method, iterative method. And you remember, but iterative method are slightly, we have to do long procedure, because iterative method we have to check may converge, may diverge, because in chapter number 2, we discuss all the over iterative methods. So iterative method may be converge, maybe diverge. If converge, maybe slow or fast. Iterative method always need initial approximation to start. Iterative method always needs stopping criteria, because in exam, teachers say find the first approximation, the second. The same thing we have to discuss in the case of chapter 2 and here. Exactly the same way we have here now. In the iterative method, we will discuss 2 methods. The first one, I give you a small idea, then we continue next time, inshallah. A Jacobi method, one of the simplest method in the iterative case. But as I told you, simplest thing is not very good one. So if you remember in the case of chapter number 2, we discussed first method, which we call is a bisection method. And I told you bisection is a very simple to use, but it's not a very good method. It's very, very slow convergence method. The same thing happen is with the Jacobi method, is a very simple one. And how can we find the formula of the Jacobi method? It's very simple here. You are given system of 3 by 3. So what you have to do, you have to find the Jacobi formula separately. Jacobi formula for first variable from the first equation, and Jacobi formula for second variable from the second equation, and the Jacobi formula for third variable from the third equation always. This is the first point you remember. Second point, when we do the iterative method, the given system, the diagonal element A11, A22, and A33 should not be equal to the 0. Now, what you can do, you find x1 from the first equation, take all the term on the other side, and then taqsim by A11. So you have this. This is the formula for x1. And formula for x2 is this. You take all the term on the other side, taqsim by A22, and you have the shape of x2 is like this one. And the same way you can find out x3 from the third equation, and you have this shape. Now, because we need initial approximation to start, and this is the initial approximation given by the teacher. And that initial approximation we use in the right-hand side. And when we use in the right-hand side, we have a new approximation in the left-hand side, which is this shape of that one here. And this formula is very simple. It's called the Jacobi iterative formula for the system of 3 linear equations. So very simple. Take the formula of x1 from the first equation, formula of x2 from the second equation, formula of x3 from the third equation, and then continue like that. And the similar manner, this I give you, the Jacobi iterative formula for any linear system, for any linear equation you have here now. That is the Jacobi method, small idea here. We discuss in detail, inshallah, next time. Jacobi method may converge, may diverge, but if converge, it converges very, very slow here. This is some basic point for the Jacobi methods we have here now. Any question now, please? Before I take the attendance. So please remember that one here. We are in the 43 student, and today Majood only 33, and the 33 joined me late. Next time, what I do after the 5-minute start, I will take the attendance. If you join me late, I will not put your attendance, please. Yeah, this is not a nice way that you just join me in the end of the lecture here. And this is not a nice, and you did a very, very bad, your quiz. It's not a good quiz you did, please. You did very bad quiz. My student in last 20 years never have a such marks. Wallah, this is the first time my student has a very bad marks. So next time, please, if you are late, I will not make you attendance, please. Number 1. Number 2. Number 3. Number 4. Number 5. La ilaha illallah Muhammad Rasul. Number 7.
Yes, doctor.
Sorry, number 4.
La ilaha illallah. You see this one here. If you are not majud properly in the lecture here, therefore you have a bad quiz here. Number 8.
7, doctor. Yes.
Yes, 7 is okay.
Thank you.
Number 8. 9.
Yes, Dr. Migran.
10. 11. 12. 13. I will put inshallah the Harman here. 14.
Yes, Yasir.
15. 16.
Ahmed, 16 Ahmed.
17.
Yes, Faisal Abdurrahman.
18.
Abdullah, present.
19.
Saad present.
Muhammad, doctor.
No, is 19 is Muhammad bin Fahad.
Yes, present.
Yes. 20 Saad bin Nasir.
Yes.
20, please, you are. 21.
Okay.
21 Yazid, yes.
Okay. 22.
Abdullah, yes.
23.
Yes, Doctor. Al-Walid.
Yeah. 24.
Yes, Muhammad.
25.
Yes, Mansour.
26.
Yes, Dr. Abdulaziz.
27. 28. 29.
Yes, Faisal Abdullah.
30. 31. 32. 33.
Yes, Dr. 33.
34.
Abdulaziz, yes, doctor.
35.
Yes, Dr. Shari.
36.
Mishal.
37.
Umar Abdulaziz.
38.
Yes, Muhammad.
39.
Yes, Khalid Nasir.
40.
Yes,
41.
Abdulaziz Abdurrahman.
41. 42.
Yes, Ahmad.
And 43.
Yes, Usama.
Class, huh? You continue inshallah.
Doctor,
Yes.
I send you email after the quiz. I did the submit in the last second. Then I press OK